Buenas tardes. ¿Me escuchan? ¿Me escuchan bien? Good afternoon, Ricardo. How's the sound? How's the view? So, as promised, today I'm going to finish off these notes, answer any questions you have, go back to the review or the old exam that I showed you last week or last class and discuss it some more. So I asked you to watch the videos regarding these notes, and the notes ended, or the lecture ended about here. Is that correct? It ended here. And it explained the incremental project, and this is what you have to analyze to compare two projects, or in other words, analyze or conduct a mutually exclusive project analysis. Does that sound familiar? Do you have any questions about this before I continue? Any questions? Just waiting to hear from you. Everything's fine? You understood this? All right, so you have practice with it. So at this point, what you learned about was independent analysis, determining whether a project was viable or profitable using different techniques. NPV checked to see if the dollar returns were greater than zero. If the if the returns, the NPV, was greater than zero, then you should pursue the project. When comparing projects, so the other approach, the mutually exclusive, you should choose the one with the higher NPV if you can only pick one. Then I talked about the discounted, or let's say, the payback period. And that rule gave you a number of years. It could be in months as well, but I showed you how to calculate it for years and to be precise in terms of decimals within the year. And it's an approach that helps determine for you to communicate to the decision makers, if you're not the decision maker, the time that needs to elapse before you recover your initial investment. I explained that the problem with just doing that is ignoring the time value of money. So we introduced the discounted payback period rule. And again, you get amount of years, but you account for time value of money. Both of these rules are providing different information than the net present value rule. So these can be used together, right? They could supplement each other. In fact, it's advised to also compute the NPV because the NPV uses all the cash flows. The problem with the discounted payback period and the payback period rule is that once the threshold is met, once you hit the number of years that is going to be your cutoff, so don't take any projects with more that require more than 3 years to recover costs. Once you've hit that, you sort of ignore the cash flows after that. You essentially ignore them. So you do want to look at them. That is added information. In fact, if a cash flow is really high in the future, although it doesn't pay off in time, that needs to be considered. Okay, and that needs to be communicated. If you're not the decision maker, it needs to be communicated to the key decision makers. And a way to do that, a nice way, is to use the NPV, because it takes care of discounting and time value of money and uses all cash flows. All right, so then I introduced the internal rate of return because the problem with, so let me say, the internal rate of return gives you the percentage required rate of return that would give you like a break-even project, an NPV of 0. And this number can be used to compare against the required rate of return that you're currently using. And if it, depending on if it's an investment or a finance project, it can indicate whether the project is worth it. And this fixes the problem with the NPV, the problem being to calculate it, you already need a discount rate. Rather, the internal rate of return gives you a range of discount rates that are going to lead to a positive NPV. So that gives you even more information, right? And now the last rule that I'm going to introduce in this class is called the PI, the Profitability Index. And this gives you a ratio. So they're different metrics, right? Dollars, years, percentage, and ratio. And they have different strengths and different weaknesses. And to end off this unit, what I'm going to do is talk about which one, given research, which one is it that managers actually use, right? Any questions so far? Okay, so I'm going to show you the profitability index and then when it's good to use it. So here's an example. Here's your initial outlay of $1,100. Here's another name for interest rate for our formulas. It's called a hurdle rate. So this is a hurdle is like a barrier, right? An obstacle. And you can run a hurdles heat in a competition, a track and field competition. You have to reach over that hurdle to continue running. So this is the 10% that a project needs to exceed to be, it has to have a return on investment more than 10% to be viable or worth it. So here are the cash flows, a very simple layout of cash flows. So what's the net present value? The net present value, we know how to calculate that. And from there, I'm going to show you how to get the profitability index. Oh, sorry. It's down here. So here's the NPV. The NPV is positive, so it implies that you should invest, right? The profitability index is actually a ratio rather than, which makes the NPV. It's a ratio of the present value of cash flow. So just this part divided by the initial investment. So it takes those, rather than adding those amounts together, it puts one over the other. Okay, so it takes this amount, which is actually, you could get it by adding back the initial investment that you just subtracted and then dividing by the initial investment, and you get 1.2. And what you do with that number is compare it to 100%. So that would be what you have to surpass, right? It has to be better than just getting back your investment. So in this case, you would accept the project. So this is a good project according to the PI rule because you get a bang for your buck, right? You get more back than you invested, 1.2. Questions? You can text me if you don't want to write in the chat. Okay. All right, so what about it? It turns out that the profitability index has, well, you're calculating using the same information as you would for the NPV, but it gives you a certain advantage, and that is for capital rationing decisions. Remember, at the beginning, I explained there's 3 types of analysis we're going to do, right? There are the independent project analysis. There are the mutually exclusive. And then there's capital rationing. And I didn't spend too much time talking about it, but I'm going to talk about it now. So independent projects is just when you evaluate each project on its own merit. Mutually exclusive is when you compare projects and you can only pick one. And capital rationing is where you have enough capital, you have enough financing, you have enough to spend on more than one project. You could possibly spend on 2 or 3 or 4 projects, depending, rationing, like spreading out, distributing that capital to the projects. So it could be more than one. All right, so here's an example. There are 3 projects. We have $20 million to spend or invest, let's be clear. So you have to choose between either project 1 or both projects 2 and 3, because that will be $20 million investment. Now, looking at this information, which one would you choose? And why? I'm waiting for comments. You guys can tell me you have no comments or you don't know so that I can continue. If you're thinking about it, let me know. All right, so you guys give up. All right, so which one would you pick? Well, throughout the lectures, I explain that whatever you do, it's usually the NPV rule that gives the correct answer. So in comparing project 1 with 2 and 3 together, adding 2 and 3 is allowed, all right? So adding the NPV of these two would give you, it's greater than $50.47. So it looks like you should pick project 2 and 3. Okay, but you would have to add them to compare to project 1. So it should be projects 2 and 3. A quicker way to see that is to look at the PI. Okay, so these are the PI calculation. The way it was made was taking the present value of future cash flows and dividing it by the 20 million to get this ratio. In this case, each one. Now look, if you rank these, if you put them in order, it shows you that the top ranked PI are project 2 and project 3. So you get the right answer that way as well. Okay? So to spend the $20 million, we should pick projects 2 and 3 according to the NPV rule, but also according to the ranking of the profitability index. So that's new. I never explained that before. I never showed you that it could be, a ranking will work when choosing between projects. In fact, with choosing between projects mutually exclusive, looking at the internal rate of return, we actually had to analyze the incremental project, remember. Okay, any questions about this? If you've read through it. So I'm going to scroll down because I know I wrote it here. So you guys can read through that. I'll wait to see if you have any questions. So I've printed them as PDFs with 2 pages in case you want to print them out, right? No comments, questions? All right, last slide. So which ones do executives actually count on? The percentage of CFOs who always or almost always use a given technique was studied in this paper published about 20 years ago. And it turns out where these are standard techniques, the most popular was the internal rate of return. And that's because, I presume, I imagine, because you don't have to be bound to a particular discount rate. Okay, so IRR will give you a list or a range of discount rates that you could use to determine if your project is worth it. NPV is a close second. Essentially, calculating the IRR, you're within trying to find a range of discount rates where the NPV is positive. It's actually calculating the NPV each time. So you're using NPV in tandem with the internal rate of return. So I can see those being a close second. But then a far third is the payback period rule. And look at this. Nobody cares about, well, I'm going to say nobody, but it looks like it doesn't matter to discount. If you're going to use the payback period rule, it's just a back of the envelope type calculation, and that's how it's probably used. And no one pulls out Excel or their financial calculator to make the calculation. They just simply look at the cash flows, the future cash flows, and add them together to see when the investment will pay back. And then the profitability index is lower down. Well, it's last. And that might be because the internal rate of return and NPV do provide the information that they need, or maybe they aren't looking beyond choosing between one or two or three projects, and so do not realize the benefits of using the profitability index. So it's the least popular. All right. So I just thought to explain to you or show you what is practical, like if these are actually used, and in fact they are, and the popularity is ranked in this study. And I don't have any reason to believe things have changed, but I should see if there's an update to this study. I always check, well, I check routinely, but I haven't checked lately. Any comments? So I have the feeling that you have not yet completed your review of the video. Okay, so make sure you get the time to look at that. That's where your information is on how to conduct evaluation of alternative investments. After this unit, we will focus mostly on IRR and NPV, but you should know the other ones and you shouldn't forget about them in the future, okay? I'm not sure what your plans are for after this course, but maybe, you might want to, well, anyway, this information you can put into your formula sheet, and then when you finish the course, you hold on to the formula sheet, and maybe you won't download all the notes from the platform, but you'll have your formula sheet as a reminder of what you learned. Your final formula sheet. So you should be preparing a sheet of formulas as, for yourself, like a summary. I've given you summaries in Unit 1, I gave you a summary. Or Unit 2 and Unit 3, I've given you summaries. So you could also just print up those so that you have that information for when you take future classes, or if you do one day think about writing any CFA exams. All right. No comments? So I'm going to return to this. Let's see how you did. I asked you to attempt these exercises in preparation for today's class. So at the end of last class, some people had written their answers into the chat, and I don't mean to ignore them, but I wanted everyone to have a chance to work on the exercises before I gave the answers, and I did not give the answers. I didn't put the answers into Moodle. So I saw people wrote C for the first one. What is your answer today for number 1? Ricardo still C. Kathy, good. Okay, so Kathy is correct. Okay, Ricardo is half right. So yes, it should be like, where does that cutoff come from? All right, so if you've read through the notes, I don't think I mentioned it today, but that is a disadvantage. It is a disadvantage of the payback and discounted payback period rule that someone needs to come up with the number of years. And what is their rationale? There's no systematic way to come up with the number of years. It's kind of arbitrary, and it is arbitrary, really. See, even I mentioned today that you could tell the decision makers that, okay, well, in fact, there in a couple of years more, if we give it a couple of years, we're sure to make double our investment in the third or fourth year. So we should just wait. That extra information might change the cutoff period. So it's really not set in stone. All right. It's not like, for instance, the NPV rules that the NPV just has to be greater than 0. So it's nothing like that. It's arbitrary, and it can create problems. It's subjective. Okay, very good. Ricardo got half of it right. Kathy got it right. Good. Let's go to the next one. Let's see. What did you get? And I'll make comments on the next one. So hopefully you had some time to try these. I'll circle the right answer. Any luck? Are you calculating? Okay, I'll start writing my answer. This is the statement. This is how we're going to calculate IRR. We're going to set the NPV to 0 and solve this. Now we can't solve this analytically, okay? I make it clear that we cannot solve this analytically because isolating for IRR is impossible because you have it in this, it's a polynomial. So we're going to lean on the finance calculator to do this job for us. First question is, did I do it right? Is there anything else I need to do? And what kind of project is this? So the idea is Green Tree is deciding whether they should pursue this contract with the government. Government's going to pay them $300,000, and then they're going to have expenses to operate and to meet the expectations of the contract, to remove citrus trees. So we go to the finance calculator and we enter these numbers into the CF keys and ask for the IRR. And we're going to analyze this as a financing project because the first cash flow is a positive and the rest are all negative. Or you can say financed project, because the money is coming up front and then they disperse the funds to meet the expectations of the contract. All right, so let's go to the financial calculator. Let's hit our CF keys and see there's something in there. So I need to hit second clear work to clear it out. Now I'm going to put 300,000, 1, 2, 3, 4, 5 zeros. Enter, and then it's a positive, and then I put an 85, 1, 2, 3 with a negative, enter, and there's going to be 5 of those. So when I scroll down, I can say 5 and be done with it, enter, and that's it. And then you can ask for the IRR, press IRR, compute, and you get this number. So looking at the options, I'm going to round it to 12.86. Does anybody want me to recompute that? I can do that again. So note a couple of things. One is that I wrote the IRR as the NPV equals 0. Okay, if you don't write it like that, I might get mad and depending on your answer, give you no credit. Depending on the question and the answer, I might give you no credit. So what do we do with this number? This is a finance project. It means that this represents the borrowing rate. So how do we conclude? Usually with an investment type project, the IRR must be higher than the required rate of return, or the discount rate used to analyze the project. If it's a finance project, it's the reverse. The signs are reversed, but also the decision is reversed. So the required rate of return must exceed the internal rate of return. So that means the answer is, which one? Well, Gabriela asked me, what's the reason for the 0? I just saw you posted that. The IRR is solving the break-even NPV. So it's solving where you begin to invest in the project. A required rate of return higher than that would make this number positive. You see, if this was higher, then these would be smaller negatives, and that would make this more likely to be positive. So it's just a break even. That's why we have a 0 there. I hope that answers. Okay, you're giving me answers now. The answer is that I wrote it here. So the hurdle rate, the way that question ends, so that's, I think that's all that's happening here. The discount rate is greater than this number. So it's C. So who got it? Gabriela got it. Kathy got it backwards, which is common. You have to get it clear in your mind. So the discount rate, so usually the return on investment in an investment project, the return on investment must exceed what was required. And now we see the internal rate of return as a borrowing rate, so our required rate of return must exceed the rate of borrowing. It has to be worth it. So things flip around. So that's on the summary page too, if you forget. But just think of it like this. Just look at the equation. If this number is higher, then this whole number on the bottom will be higher, and it brings this number down. So that will happen in each of these. So you'll have a smaller negative, which will allow the 300,000 to overcast these, and you'll get something greater than 0, and that's what you want. So again, still it's the NPV rule happening, that you need to have NPV greater than 0. But we're not stuck with a discount rate. We get a whole range. As long as it's greater than 12.86, we should pursue the project. It's okay, Kathy. Now you'll never forget, right? All right, let's go to the next one. Oops. Oops. All right, let's do this. They're not attached. Let's go out and back in. All right, so let's try this one. For those ones still writing, I'll make it visible. All right, so let's try number 3. So again, another term for the discount rate or the interest rate. Opportunity cost of capital is 12%. Hurdle rates, these are all the same thing. Essentially, mathematically, they are the interest rate you'll use in the formulas. Okay, we almost have a half hour left. We should be able to finish this test. Actually, I didn't want to spend the whole class on the test, but it looks like I will. So next class, we're going to start Unit 4. So we'll have 2 days of Unit 4, or 3 days. I have to check again about when your test is. Right, we have till the 29th. So we have 3 classes. We'll have 3 classes to do Unit 4. That's great. Great. But you have to finish studying this on your own, okay? Practice everything. So then, and even, oh, I have to open Unit 4. Did I open it? So you can start reading about Unit 4, and I should put problems up and connect as well. Okay, no, I didn't open Unit 4 yet, so I'll open it today. Okay, you should be calculating away. I'm waiting for you to give me some answer options, possible answers. How's it going? No takers yet? Are you calculating? Are you waiting for me? Don't wait for me. I want to see one guess. Any guesses? And then I'll start computing. Or near guesses. I don't want to discourage you from trying. Okay, Kathy's gonna say E. And Kathy is right. You got it, Kathy. All right, so let's calculate each one. I want you to check NPV. NPV is, so in a test situation, you need to write these things out, right? And send it to me. Remember, you can't just guess the answer. You have to show me your work, okay? So NPV is equal to negative 20,000 plus, okay, so then you have to write this long equation. It's 4 of them. And then you put that in your calculator to get the answer. Let's just do it. No. All right, back to CF. There's something there, so we should second clear work. And we put in 20,000. Now this is a negative. Enter down, and then 7,000s are going to be positive. 7, 1, 2, 3. Enter, and there's going to be 4 of them. So you say 4. Enter down, and you're done. Just checking. That's it. That's all. So then you say NPV. You tell the calculator that it's a 12% enter down rate, and compute. And so you get 1261.45. Good. So the first one is correct. The next one, okay, you have the numbers in there already, so now just ask for IRR. Let's go. So now ask for IRR, compute. It's 1496. Should I do it again? Just ask for IRR and compute. Well, I can't take it out now. So that's true. I'm just going to put true beside it. The project will have more than one IRR, right? How do we know about that? Well, there's only one sign change, so there's only one IRR. So yeah, it's true. And finally, the PI is 1.06. To calculate the PI, remember you use the present value of future cash flows divided by the initial investment, right? And I make it a positive. Just don't forget that, because we're not going to get a negative PI. Okay, no negative PI. I'm going to put the positive version of the investment. And since I have the numbers as the NPV, what I'm going to do is take the NPV and add and subtract off the initial investment, or add it back. And then over 20,000 as a positive. So my PI is 1.06 when you make the calculation. Let's get the NPV back. Okay, and let's add 20,000 to it. Oh, wait. Let me get the number again. It's a positive, right? Yeah, and then add 20,000. What did I do wrong? I'm going to take it off, not add it. I'm going to take it off because what I have to do is just the present value of future cash flows. Yeah, no, it has to be added back. Just to remind you. Right, that's what we do for the formula. Oh, it's up here. No, it's here. Actually, I should put the CO as a negative. I should actually have absolute values here. I don't know why I didn't do that. Okay, so CO. All right, so I know why, because what I've done is called, I think I put it into the formula sheet. So CO is like your initial cash flow. It's like the positive of the initial cash flow. I'll just write like that. Which, how do I write it? Anyway, I'm trying to get I know I played with this to make it clearer. Okay, so whatever your initial cash flow is for investment projects is going to be negative, so you have to take the positive of that. That's why I call it CO. Let me double check here. I don't think I mentioned it again. Okay, I think it's just on the formula sheet that I put it. And sorry. So I don't need to put the absolute value signs if I'm using the notation CO. The point is, it's just the positive of the investment. And you're taking the NPV, adding it back. Okay, so back to what we were doing. So you get the NPV, add back 20,000, and then divide by 20,000. You see it's more than 20,000, and it's 1.06. Comments? Did you see what I did, Gabriella? So to get the PI, you have to get the NPV from the calculator and then add back the initial investment as a positive, and then say equals, and then divide by the initial investment. So either you would have, to get this, you have to add the initial investment, right? All right, so that's true. That has to be bigger than 1, so E is the answer. Got it? All right, next page. Okay, try that one. How's it going? Which one do you pick? Any guesses? Okay, no guesses. All right. Is this hard or something? Hard Choice Corporation is a firm considering prospective capital budgeting projects. Selected data on the projects are: consider only projects A and B by examining the incremental project cash flows B minus A. They are mutually exclusive opportunities. If the internal rate of return is 12% for the incremental project and the discount rate is 15%, then what is your decision? So what this means is, okay, first of all, I need to see the signs. All right, first I look at the signs and I see it's positive and negatives. As positive and negatives, the incremental project is financed. So the project B minus A means choose B not instead of A. So you're going to choose B minus A in the case of this financed incremental project when, what did we just say before? To be financed, it means that the required rate of return must exceed the internal rate of return. So is that the case? The required rate of return is 15 and the IRR is 12, so we should take B instead of A. So that is what I conclude. Well, which is the right answer? Since IRR B minus A is less, then since the incremental project is a finance project, we should accept B over A. I don't know, that looks like the right answer, doesn't it? And it is. And these are just twisting everything around to confuse you. Questions? So remember, an investment project is when you put money out of pocket and then that's a negative cash flow, and then you have net cash flows that are positive throughout the years. The future cash flows are all positive. The opposite, or the finance project, is when the initial cash flow is positive, so you're getting money, right, to operate. And so then these are the disbursements of the funds. So it's positive and then all negatives. All right, no, too much from you guys. Let's see, we're almost done, right? Number 5. Hope you're learning something. Let me know if you're not. This is going to be the last set of problems I share other than what I give you in Connect. Ignoring the information in question A. What happened? In question A. Why did I call it question A? I guess it's question 4. Assume instead that projects A and C, or maybe A? No. Sorry for the typo. Assume instead that projects A and C are independent. Assume instead that projects A and C are independent. So that means you could pick both as long as they satisfy the criteria. Hard Choice is subject to capital rationing. It may not be able to afford both projects. And the relevant discount rate is 10%. How would you rank A and C? So A So you notice what we have to see here is that A has a timing issue where, well, the comparison of them two is that you pay a lot more, or you invest a lot more up front for A, and then you realize increasing returns. So it's kind of like, it's different timing, but it's also scale of the project. And then for C, this one, it's half the investment and then just steady returns. So what's going on here? All right. Assume it's in the independent hard drives. Okay, how would you rank A and C? So here are some options. Let's look at the internal rate of return. If we look at the internal, if we look at the internal rate of return, something's happening with my Apple Pencil's not connected for some reason. Can't be broken. Sorry, a second. Wow, my pencil just broke. All right, Apple Pencil. It's possible. Shouldn't be broken. Okay, I'm gonna just have to use my finger. So IRR of project A is 14%. So you should check that. And IRR of project C is 41%, so A is better than C. All right. Remember, for capital rationing, what did I just teach you? For capital rationing, you should be using profitability index. Okay, so that's the key thing you need to learn here. So although they're showing you IRR, go to the PI options. And profitability index, get the NPV of A, then add back the 400 and divide by 400. That's what you have to do. And do the same thing for C. It's not going to be great because my finger is not so precise. I probably have to do some sort of update on the pencil. Okay, I got it back. I got it back. Let's use it. So PI of C is equal to the NPV of C, add back 400, divided by 400. And the PI of A, sorry, C is 200. So I'm going to call this the PI of A. So the PI of C is NPV of C, add back the 200, divided by the 200. I hope you can see that. So let's get the NPV of A. Okay, 5 more minutes. We can finish this one. Okay, go to our CF keys and second clear work. And let's do A first. So NPV of A is 400 negative. Enter. I mean, I could just get the PV. Let's just do that. Let's just get the PV with our calculator. So if I want to do that, then let's clear this again. In CF0, we put a nothing, right? And we just enter it and pass to C1, which is 100. Enter down, down, then 110, enter down, down, then 120, enter down, down, then 130, let me know if I make a mistake, and 140, enter down, down. So let's look at what we have. Nothing, and then we start with the future cash flows. All right, so that should get it for us with a discount rate of 10%, right? So we forget about what they said in the first problem. So then we're going to get the NPV with 10%, enter down compute. So that should be the present value of future cash flows. I'm going to store that. And then we divide it by the investment, 400. So it's a 1.12. It's 1.12. And then for C, are you ready? Do it again. So we're going to get the PV of these, but don't mention this one. Just do this at year 1. Let's just put a 0 in there to get the present value of future cash flows. And divide by 200. Oh, sorry. So let me say that again. So it's just hundreds, 5 years in a row. So that's easy, right? Because we can get this up, clear it, then start entering 0 for CF0, and then 100, enter, and we want it 5 times, enter, and we're done. And you're computing NPV at 10%, it's 379, and divide by 200 this time. It's 1.9. I'll redo that if you want, but you see my numbers are working out. So I must have done this right. All right. What would you like me to repeat? All right, so the answer looks like it is C, and time is up for this class. So have a look again at this video if you didn't follow that. All right, and next class I will finish. How many more problems do I have here? 6. Oh, and then the end. Okay, so that's it, just one more. So next class I'll do the last one, and then I'll start talking about Unit 4. Okay, so I'm going to open up Unit 4 now. I'm going to look at preparing the Connect problems. And any questions for me? before we go? So buenas tardes. Have a good weekend. Okay. So Unit 4 is going to be about teaching you how to derive your own schedule of cash flows. All right. So so far I've been giving them to you, but where do they come from? That's what we're going to talk about, and we're going to be preparing a projection of cash flows. Bye.